right, we are going to take this one-to-one rational function and we're going to find its inverse. We're actually going to find the inverse function of f of x. Along the way, or towards the end, we're also going to find the vertical asymptote, the horizontal asymptote, the domain, the range, and the y-intercept. Okay. To find the inverse, we simply create a new problem. The first thing we want to do is switch the domain and range. And the way we do that is actually, f of x is a y value. So what we're going to do is we're going to call f of x is going to be our new x. And our x's are going to be our y's. Now we're going to solve for this new y. 7xy plus x is equal to 5y minus 8. We're going to collect our y's. So let's try 7xy minus 5y is equal to negative x minus 8. I have a common factor of y. And notice to solve for y, we need x to not equal 5/7. That allows us to divide. So remember to state that x is not equal to 5/7 before you divide. We don't want to divide by 0. Now let's rename this y. This is our inverse function of f. And there it is. We have our inverse function. Let's find its vertical asymptote. Remember, to find a vertical asymptote, you could actually spot it with this domain implication. You could actually see that the vertical asymptote is x equals 5/7. Let's find the horizontal asymptote. The horizontal asymptote occurs for a rational function when the degree of the numerator is equal to the degree of the denominator. And then we actually look for the coefficients of those highest degrees. So in this case, the coefficients is a -1 and a 7. So our horizontal asymptote is y equals -1/7. With the vertical asymptote, this helps us state the domain. The domain of the inverse function is from -infinity up to 5/7 union 5/7 up to the concept of infinity. With the horizontal asymptote, it helps us state the range. The range of the inverse of f now equal to -infinity up to -1/7 union negative 1/7 up to positive infinity. So we got the vertical asymptote, the horizontal asymptote, the domain, the range. Only thing left is the y-intercept. So remember, the y-intercept occurs when x is 0. So let's use our function notation. X is 0, and let's find its output value. The input is 0, and the output is always a y value. So we have 0 minus 8 over what now? 0 minus 5. So our y-intercept has an ordered pair. If we translate our y-intercept into an ordered pair, we get 0, 8 over 5. There we go. We got a lot of things here. Let's circle those items that we stated earlier. Here's the vertical asymptote. Here's the inverse function. Oh, it'll be better if I actually circle this part as well. We have a horizontal asymptote. We have the domain. We have the range of the inverse function. And then we have the y-intercept. There we go.